Welcome back to the deep dive. So today we have this really interesting problem on the table.
Yeah.
How do you get a 4K video signal across a huge building
Yeah.
without, drilling holes and running hundreds of feet of expensive cable?
Or spending a fortune on fiber you don't really need.
Exactly. And the solution we're looking at is this little blue box, the Kramer KDS-EN6 video encoder. Our mission today is to unpack how this thing turns a standard IT network into a high-performance AV system. This is AV over IP, for real.
It really is. It's where those two worlds, AV and IT, properly meet. You're basically telling a video signal to behave like regular network data.
Okay, let's get into that, because regular data and 4K video at 60 frames a second do not normally, get along on a 1 gigabit network. The raw signal is it's massive.
Oh, it's huge. And that's why compression is the main story here. The KDS-EN6, it's using the MJPEG standard.
MJPEG. That's interesting. I mean, it's an older standard compared to something like H.264 or H.265. Why would they go with that?
It all comes down to latency versus quality. See, MJPEG compresses every single frame by itself. This lets them shrink that 4K signal, specifically the 4.2.0 version, down to a manageable size without the big processing delay you sometimes get with more complex codecs.
So what are the numbers? Let's talk bandwidth, because any IT manager listening is going to want to know that.
Right. So you're looking at a peak bit rate of around 850 megabits per second.
Ooh, that's a little tight on a standard gigabit switch.
It is. You have to be mindful. But the key is that the average for 4K is much lower. It's closer to 350 megabps. So you just need to account for that headroom. You don't have to go rip and replace with 10G gear everywhere.
That's the real takeaway then. High quality video, but on the pipes you already have. Now here's where it got really cool for me. It uses RTSP.
Yes. And that opens up so many possibilities. It's not just a point-to-point connection anymore. I mean, you can do unicast one-to-one. That's fine.
But you can also do multicast.
Exactly. One encoder feeding, say, 50 different screens. A true many-to-many setup. And because the connection is virtualized, you're sending more than just the picture.
What else is on there?
You're sending the control signals, IR for remotes, RS-232, and even USB. It's all riding on that same network stream.
Wait, hold on. If you're sending USB over IP with the video, does that mean I'm basically getting a KVM switch for free?
Pretty much. You can plug a keyboard and mouse in at the display and control the source computer from across the building. It's incredibly handy.
What about the audio? Did they crush it down to nothing?
No, not at all. It handles 7.1 PCM, Dolby True HD, and DTS HD master audio. So the sound quality is, top-notch. It won't be your bottleneck.
I also saw something in the docs about scaling and cropping. To me, that sounds a lot like video walls.
It is. You don't need a separate, expensive video wall processor. The encoders themselves can do the math to stretch one image across a whole bank of displays.
That cleans up the equipment rack quite a bit. Okay, so speaking of clean, what's the actual installation like? If I'm the person on the ladder, what do I need?
You just need a network cable. That's it. It's got PoE.
Power over Ethernet. That's huge.
Huge. No more searching for a power outlet and a drop ceiling. The 48 volts come right from the network switch. You plug in the CIT cable and it wakes up.
And for managing it, you've got options, right?
You do. There's the big Kramer network platform, a simple web UI for individual units, and an API if you want to write your own custom controls.
Plus, and I love this, there are actual physical buttons on the front for changing channels.
It's the perfect failsafe. Never underestimate a physical button when the network's acting up.
Okay, one last practical thing. Copyright. HDCP. If I try to play a Blu-ray, is the screen just going to go black?
Nope. It's fully HDCP 2.2 compliant. It handles all that protected content without any issues.
So to sum it all up, we have a device that puts 4K video, high-end audio, and all your control signals onto the local network you already have.
I mean, if you step back and look at the big picture, this kind of technology is moving AV away from specialized single-purpose hardware and into the software layer.
Which leaves me with a final thought for you to chew on. If the network switch is now doing the job of routing video, audio, and control, are we watching the slow death of the traditional AV matrix switcher?
That really is the question, isn't it? When your network becomes the matrix, all that old clunky hardware starts to look like a dinosaur.
Something to think about on your next project. Thanks for diving in with us.